Hey everyone, welcome back. Today we are going to understand convolution as a mathematical operator. We'll keep it simple, intuitive, and at the end of the video it all just makes sense. Convolution is just an operator, just like addition, just like subtraction, just like multiplication, just like division. It's also similar like convolution. Mathematical, it is just a mathematical operator. So what does it actually mean? Okay, let's say yt is a function, y is a function of t, x of t into it with some any other function h of t, let's suppose. Okay, so but what is actually doing? Simple answer is it's measuring how much two function overlap as one slides over the other. How, I am repeating again, listen carefully. It's measuring how much two functions overlap with another as one slides over the other. How much two functions overlap with each other when one function slides over slides over with another. The formula look like this. Over the range of a time period. Not time period. So it's measuring how much two functions overlap as one slides over the other. So formula look like this. The things have three things happening here. First of all, when h of t, it's h of tau, because t is a constant here and tau is variable. So with h of tau replace with h of tau minus tau, then shift minus tau with the small t. Small t is somehow constant, and then at the end multiply with xt over a range of time minus infinity to infinity, where up to their extension it depends on functions. Okay, so take with an example. Okay, take two rectangular pulses example. We will take example, you will understand also very at the end. If you are not understanding, then please wait. Once you see the at the end of, once you proceed at the end of the video, you will know and feel the what actually convolution means. 0 to t 1, let's suppose, is xt, and there is another function h of t is also from 0 to 1. So what is actually doing? When I tell you in the starting that it is telling how much two functions overlap as one, how much two functions overlap when one slides over the other. This is not automatically we will overlap, we will directly overlapping, we will forcing him to overlap, so we can finding the output of, after the overlapping. Okay, so in this case at first no overlap, output is 0, because the range is initially range is 0 0 0, the output will be 0. But over a range of a period, range of a time, at first overlap output is 0, but as it slides overlap grows, as it slides when h of tau minus tau and shift it at times small t sum, it will grow, then at a somehow it will goes to a maximum range, and then after that output falls back then back to 0. It's a triangle. So what's the convolution of a two equal rectangular pulses? Is a convolution. Okay, it's a simple convolution. The result is a triangle, two simple boxes, one smooth triangle. That's convolution. So but in the signal system, the output of any LTI system is the convolution of the input with the impulse response. As I write earlier, yt is equals to xt. Output is the convolution of input with impulse response. So what's the whole story? That we will use the convolution in image processing, in a machine learning. Blurring and sharpening are convolutions. In probability, adding two random variables means convolving their distribution. One operator used everywhere. So convolution flips one function, slides it over another, and records the overlap at every point. Simple idea, very powerful operator. Okay, so that's a real analogy. Hope you will find it helpful. Thanking you to seeing the video.